Assalamu alaikum. Today I will follow the guided lab 4, which is the time series data prediction. So for the overview, in this lab you will prepare a data set for constructing a forecast by using Amazon Forecast. This lab includes 2 Jupyter notebooks. First, this notebook contains the steps that you will follow to prepare the dataset and evaluate the forecast. The forecast autorun.ipnb notebook contains the steps to construct the forecast by using Amazon Forecast. This notebook is run in the background when the lab starts, and it can take between 1 to 2 hours to complete. You will refer to this notebook during the lab steps, but you won't need to run any cells. So about the dataset, this 1 retail to online retail dataset contains all transactions that occurred between January 12th, 2009 and September 12th, 2011 for a non-store online retail organization that's registered and based in the United Kingdom. The company mainly sells unique all-occasion giftware. Many customers of the company were wholesalers. And for the attribute or information, we have invoice number, and it's a nominal, a 6-digit integral number that's uniquely assigned to each transaction. If this code starts with letter C, it indicates a cancellation. Okay, let's zoom it a bit. Okay, that's better. So for stock code, product item code, nominal, a 5-digit integral number that's uniquely assigned to each distinct product. So for the description, we have and the item name, nominal as well, and quantity, the quantities of each product item per transaction, and it's numeric. Invoice date and time, numeric, the day and time when a transaction was generated. Unit price, numeric, product price per unit in pounds sterling. Customer ID, customer number, nominal, a 5-digit integral number that's uniquely assigned to each customer. So for the country, it's the country name, and it's also nominal, the name of the country where a customer resides. Okay. Dataset attributions are here, and the lab instructions to complete this lab: read and run the cells below. Okay. So for task 1, importing Python packages. Start by importing the Python packages that you need. In the following code, Boto3 represents the AWS SDK for Python, and which is the Python library for AWS. Pandas provides data frames for manipulating time series data. Matplotlib provides plotting functions. SageMaker represents the API that's needed to work with Amazon SageMaker. Time, Sys, OS, IO, and JSON provide helper functions. Okay. So we have a bucket named in here. So we are installing and importing some libraries, and we are using this version of Pandas. So exploring the data. The data is in Microsoft Excel format, and pandas can read Excel files. Yes. Note this data might take 1 to 2 minutes to load, and I have already loaded it. So according to the description for the dataset, some values were missing. To keep things simple, you will remove anything with a missing value. Okay. Start by examining data. How many rows and columns are in the dataset? So we have this many rows and 8 columns. And what are the data types? We have invoice. These are object, but actually these may be datetime objects or simple string data in here. For example, in a country we might expect a string. Oh yes, and as you can see, the invoice date is actually datetime object, and these are string type, I guess. So let's see what does the data look like. So we have invoice and I guess this is a kind of integer type, but I'm not sure. And the stock code can include some letters as well, so it's definitely a string type. And description is also string, quantity integer. Okay. Invoice date is datetime object, and price is float. Customer ID is, it's saying it's float, but customer ID being a float value is interesting. There can be an issue related with this. So country is United Kingdom as a string variable, and Amazon Forecast has schemas for domains such as retail. Review the schema information at retail domain in the AWS documentation. So let's see that as well. Retail domain. Let's see what domains we have. Custom domains, inventory planning domain, EC2 capacity domain, workforce domain, web traffic domain, and metrics domain. We have these domains in the Amazon Forecast. So let's continue then. And okay, the target time series is the historical time series data for each item or product that's sold by the retail organization. The following fields are required. Item ID is a string, unique identifier for the item or product that you want to predict the demand for. We have a timestamp in a timestamp format, of course, and we have demand, the number of sales for that item at the timestamp. It's also the target field that Amazon Forecast generates a forecast for. If you examine the previous data, there are certain columns that you don't need for your investigation. You can drop these columns. The columns you can drop are invoice, description, and customer ID. Note, it's possible that items in the same order shown by the invoice column could have a correlation that impacts the model. For this step, you will ignore this possibility. Okay, so we are dropping the columns we don't need using this code in here, and we have all only left with the stock code, quantity, price, country, and invoice date. And we know the invoice date column is your date time data. You can inform pandas of this by using the datetime function. You can explore the data by time by setting the index of the data frame to the invoice date column. So we are taking the invoice date and setting it as our index in here. So after that, you will now examine the updated date time. The number of rows and columns are like so, and the new data looks like this. Okay, we have invoice date as our indexes. We have stock code, quantity, price, and country information. Now that invoice date is the index and it's shown in the first column. Because you set the index to your data, you can use it to select data. To select all the rows from a specific date, use the date in the index. Okay, we can now query this date. The hours is not important. You can search for this date that way using indexing. You can use parse of a date and the date ranges to view the January and February rows. Okay, for viewing January and February rows, we can simply use this indexing like so, and the date range starts from this date and it ends at this. So it's from 2009 to 2010, and which is the last month, and it's approximately 1 year of data we have. With pandas, you can extract date information easily. You might extract date information to explore the data further and look for time-related trends. Extract the year, month, and day of the week. Okay, so we are now extracting year, month, and day, and that way we are kind of, feature engineering in here. And we have, and as you can see, successfully splitted the date information into year, month, and weekday name. So the data set that you now have includes purchases made between December 2009 and December 2010. It's reasonable to assume there would be some seasonality in this data. You will now investigate whether there is a seasonality. So we have now plotting code in here to plot the value counts in the retrail, and we are using the month as the feature. So by looking at it, we have the maximum sales in the 11th month, and following that by 10, and I guess there is a seasonality, I might say, because the last quarter has the most sales. So from the chart you could deduce some seasonality. November and December seems to be higher than the rest of the year. Quarter 4 seems to be higher than other quarters. For quarter 1, quarter 2, and quarter 3, the last month of the quarter, months 2, 3, 6, and 9, seems to have spikes. Let's see as well. Yes, as you can see, the end of the quarters has seasonality spikes. That might be because of discounts at the end of the seasons, I might say. So now investigate whether there is a seasonality during the week. So and we can look at the weekdays. As you can see, in Saturday there are no sales. Maybe the wholesalers don't work at Saturdays. That might be the reason for it. So Saturdays shows very few orders. Why might this be the case? As I said, I guess this is because they don't work at Saturdays. That might be the reason. So for the third task, we have cleaning and reducing the size of the data. In this task, you will reduce the size of the data. You will also remove any anomalies such as negative prices, outliers, and country data. So for reducing the countries, let's examine the countries. We have United Kingdom, France, USA, Belgium, Australia, and other kinds of countries. We have many countries, as you can see. So if we look at the value counts, we have most sales from the United Kingdom, and followed it by Erie, and Germany, France, Netherlands, Spain, Switzerland, and so on. And we have the minimum sales in the Nigeria. So the most of the data seems to be for the United Kingdom. To make your job easier, filter the data by United Kingdom. So we are filtering our data for United Kingdom. As you can see, it's a very high rate, so compared to others. And because the country column only contains this same value, you can drop it now. Okay, that's a very smart thing to do, since we are examining the United Kingdom's sales. So and for examining stock code and removing anomalies, examine the distribution of stock code column. So if we
konuşayım.
And yes, let's continue. For examining stock code and removing anomalies, examine the distribution of the stock code column. So if we look at it, we have this many unique values for our data set. So there are 4015 unique values for stock code. A quick plot of the counts might give you some insights into how the values are distributed. So if we look at it, we have too many sales for this stock, about 3000, and this is not expected actually. And since all other stocks have sales around 500, 3000 is a really big number. So it seems there are a few high selling products with a long tail behind them. You could investigate this situation further. However, for now, let's examine the quantity. So quantity dot describe, if we look at it, we have minimum value of, interestingly, negative value. This is not correct, I might say. The maximum number is this, and these are since our mean is about 11 and we have a standard deviation of 68, these are absolutely, you know, minimum and maximum values are absolutely outliers, I might say. So if we plot our quantities, the values below 0 are all you know, anomalies and outliers, I might say. And we have some spikes in here, these locations, and these might also be some outlier data from the from the initial plot. Notice a couple of interesting aspects. First, there appear to be negative values, yes, as I said. So there, and for second, there are very large spikes throughout the year. Yes, there are many large spikes throughout the year, and negative and zero quantities could impact the forecast if you don't know why these values exist. To make things easier, for now you will remove negative and zero values. Yes, this is a good solution. If we come to price, for price we have a mean of 3 and we have standard deviation of 30. So by looking at it, the maximum value is an anomalous case, which can be an outlier, and we have a minimum value of 0, and this is also interesting. And this means that the price is 0, means the product is basically free. So this is also interesting. So if we look at it and plot our prices, we have some spikes, and these are really weird spikes, I may say. And let's see why. The plot shows some clear spikes. You will now try to find out why these spikes exist. So if we select the records with price having greater than 500, we have a stock code of M. This is an unusual stock code that it says in here. If you had an access to a domain expert, you could learn about the importance of M. Because you can't ask a domain expert for this lab, you will drop everything that contains a stock code value of M. Okay, we can easily drop it, and let's see. As you can see, our standard deviation is decreased to 4, which was 30. And this is a really big change, I might say, but still we have a maximum value of 387. This result is a little bit better, but the max value is still high. You will now investigate this situation further. So let's see, and as you can see, we have a stock code of adjust 2, and a post, and it seems that some adjustments occurred. You will also drop any data that shows these adjustments, and let's drop these adjustments as well. And after dropping those out, we have a maximum value of 295. So let's also go for the minimum values of being 0, which is a free product. Let's also examine these. And if we look at the, for example, this stock code, is really weird. Also for this as well. Well, this might be a true stock code number, but these are actually test stock codes. So there aren't many values. Let's see how many we have in total, like 700 at max, I guess. And we had let me see, we have like how many rows and columns we had. Yeah, we have well, actually let's go for the United Kingdom. Yes, we have like 379,000 records, so dropping this many is would not impact our data set. So let's split our data now. The time series data that you need to construct a forecast requires a timestamp and item ID and demand. These features will map to the invoice date, stock code and quantity columns. The related time series data needs a timestamp and item ID and a price. These features will map to the invoice data, invoice date, stock code and price columns. So let's construct two data frames, one of which would have the time series and the other one would have the related time series. So we have a stock code and a quantity. These are the main, time series we have. And we have a related time series as stock code and a price. And the price is related with the quantity of the stock. So now let's do some downsampling. We will downsample our data because, as you can see, we have time data in here as well. So this is a date time object. We ultimately want to convert this date time into pure date, which would not contain any time data. So you can see multiple orders of each day. You want to construct a forecast that predicts demands at a daily level. You must downsample the data from the individual orders into a daily total. So for the orders for each day can be summed. Yes, we can use a summation in here because the total demand for the day is the value of that you will forecast. Pandas provides the resample function for this purpose. Sum will sum the quantity column. You will also reset the index based on the invoice data, the value. However, this time it will be date without the time portion. Okay, it might take up to 1 minute for this process to complete. I have already run these cells previously, so we don't need to wait. So we are grouping stock codes and resampling for day and summing them up and resetting the index. So, and since we have reset our index, we now need to set it back to invoice data. So if invoice data, we have stock codes and its quantities in the day format, and it doesn't contain any time information. And we can also use this as well. It is an alternative way to do all the jobs in single line using the set index at the end of the code. So examine the new data frame. If we examine it, we have, as you can see, if you look at this stock code, these many quantities of sales and in this state. So in order now has a single entry for each day. Repeat this process with the related time series data. So we will also do these with the price. So the important thing in here is we are now using mean, not sum. So why we are using mean, you might ask? Because since price is a price is a value that would make sense if we had taken the mean of these values, and for example, if you sum these up, that the price of the product doesn't make sense. So if we list values, question, why are some of the previous values showing not a number? Answer, that product had no orders for those days and thus has no price. Should you fill these not a number values with a numerical values? Yes, well, let's also fill these values, and for example, we can use the pad function in here. Pad function will fill the gap using the previous value, so it's a forward fill it's using. We are now have successfully filled our values. So for the fourth and last task, I guess, we will now review the construction of the forecast. The following cells are marked down. They demonstrate the API calls that are needed to construct a forecast based on the data that you have been working with. Constructing a forecast with Amazon Forecast involves 3 stages. First, we are constructing the data sets and importing the data. This process typically takes up to 5 to 10 minutes. And constructing the predictor, this process trains a model by using the data that you provided. It takes about 30 to 60 minutes to complete, and constructing a forecast, this process generates a forecast for a particular item by using the predictor. It also takes 30 to 60 minutes to complete. To save time, when the lab was started, the forecast auto run also run in the background. The notebook will be updated with these results after running completes. It takes about 65 minutes to run, but it might take a bit longer. By the time you've reviewed this cell, the forecast construction should be in process. While it's finishing, you will review the code. Note, feel free to review the actual forecast autorun.ipmp notebook if you want some more detail. However, make sure that you don't run any cells. So let's also see that. We have, yeah, this is running. I guess. Let's see if it's completed. I guess it's have been completed. So what I will be doing is that let's continue from this, constructing the data sets and importing the data. So the first step is to construct a forecast dataset group. So we have a session in here, and we have forecast service from that session. We have a constructed dataset group response, and we are now constructing the group using the domain as retail, and dataset group ARN, and we have a construct dataset function requires few parameters. So we have a domain. This parameter specifies the domain, such as retail, that the forecast should use. So we have a retail domain. Dataset type. For the time series data, this parameter will be set to target time series. So for the dataset name, this parameter specifies the name of the dataset. Data frequency, this parameter specifies the frequency. For the daily dataset, it will be D. For the schema, this parameter specifies the schema of the dataset. The dataset schema for the time series is like so. Attribute name and attribute time. We have a timestamp attribute. We have an item ID attribute and a demand attribute as well. The code to construct the dataset is: we have a construct dataset from the forecast when our domain is retail, and a target time series and retail time series data, and the D schema, and we have ARN data set construction. Now that the dataset is defined, a job is needed to import the data. So we are now importing the data. Yes. Note that the data source is a path to the data that's stored in the Amazon Simple Storage Service, Amazon S3. The final step is to add the dataset to the dataset group. So we are now updating the dataset group by these values. So the process of adding the dataset to the related data or metadata is done in the same way. By changing the names, schema, and the dataset type, although you have prepared this data, you won't use it in the predictor because the model wasn't impacted by the additional data. So constructing the predictor, the next step is to construct the predictor. The construct predictor commands needs a few parameters, so it's predictor name, and we are using the deep ARP algorithm, and the algorithm ARN, and we have this parameter is the path to the algorithm that you want to use. In this example, you are using the deep IAR plus. So the evaluation parameters, we have this parameter enables you to specify the number and size of the backtest windows. Recall from the module that this parameter controls the size and the number of testing windows that are constructed from the data, and we have a number of backtest windows as 1, and a backtest window offset is 30. So forecast horizon, how many units to forecast, in this case units are days. So we need to predict 1 month, so that's why it's 30. And for the input data config, this parameter specifies the data along with optional vacation days. So input data config is like so, and the featurization configuration, yeah, this sets the frequency, but it's also used to specify filling methods for data. So yes, the code to construct the predictor, and we have a predictor name, and algorithm ARN forecast horizon perform AutoML is false, perform HPO is false. The level evaluation parameters, and we have input data config and a featureization configuration, like so. After that, the predictor is constructed. You can construct a forecast. So for constructing the forecast, we have a construct forecast method, and using these, after the forecast is generated, the results can be queried by using query forecast method, like so. And for after that, we will wait for the forecast construction to complete. The forecast should now be constructed. You can investigate to see whether the forecast construction is complete. So first construct a helper method to show the status, and then next construct the instance of the forecast image for the forecast query objects. So let's see class student indicator, like so. You will read the variables from the store and check whether forecast was defined. After the forecast is defined, you will not wait until its status becomes available. So waiting for the predictor ARN to be available, and it's now active. And using the forecast at this point, there should be a forecast that's ready to be queried. Check that you get the data for the following test stock code, and let's see, these are the predictions, plotting actual results. Earlier you split the data and held back the November and December values. You will plot these values against the predicted values for the same period. You will start by reading the test value back into the data frame. So these are the test values, these are the actual values, and check that you have data for this stock code, and you can do a quick plot of the data that is plotting the prediction. We have plotted the prediction as well. So I don't know why, but we don't have any we have some values in here, like so. This stock code, we don't have any value in here, but I don't know why. Well, next you must convert the JSON response from the predictor to a data frame that you can plot. So okay, so let's continue for the plotting the prediction. Next, you must convert the JSON response from the predictor to a data frame that you can plot. Start by getting the P10 predictions. So let's see the P10 predictions from our forecast. As you can see, if we plot the P10, it's looks like something like this. And the previous code only retrieved P10 values and put them in a data frame. Now complete the same process for P50 and P90. and comparing the prediction to actual results. After you obtain the data frames of the task, is to plot them together to determine the best fit. So well, I don't know why, but these are empty. So well, at least we can see the predictions, but I will try to you know, run these again to see if these would work. So I will stop the video here.